Okay, so double and half angle identities. What is that talking about? Okay, we already know from yesterday that sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta, right? And we know that cosine of alpha plus beta is cos cos minus sine sine. And we know that tan of alpha plus beta is tan plus tan plus tan all over 1 minus tan tan. So these are multiplied. Right? So the question of today is, what would happen if alpha and beta were the same angle? Okay? That could happen, right? There's no reason why alpha and beta have to be different angles.
Don't you get a special angle anyway?
Yeah, what happens? Well, not necessarily. In this case, if you're doing alpha and beta being special angles, yes, like 30 plus 30 would be 60, is that what you're saying? Yeah, you're right about that.
60 is 120.
That's right. 90 plus 9 is 180. But listen, these are true for all angles, not just specials. You guys understand that, right? These are true for if alpha is 1 degree and beta is 14 degrees. You see what I'm saying? So these are always true, as long as the alpha is not forbidden. Like alpha cannot be 90, for example, in this problem, because then you have undefined. But don't always think special angles, you know? But what would happen if we let alpha equal beta? This would modify our equations a little bit. For example, sine of alpha plus beta would not look like sine of alpha plus beta anymore. It would look like sine of alpha plus alpha, supposing beta was alpha, see? So instead of writing sine of alpha cosine of beta plus cosine of alpha sine of beta, you could write sine of alpha cosine of alpha plus cosine of alpha sine of alpha. Everything's alpha, see?
2 times sine of alpha.
Don't shout out answers, okay? We have sine 2 alpha equals, that's how you would write the left side, and 2 sine alpha cos alpha is how you would combine the right side. So this becomes a brand new identity for us. It's not that useful all the time, but it's a truth, and it should be written down, and it should get added to our formula sheet. So I'm going to add it over here. This is called the sine double angle. And it's sine 2 times an angle is 2 times sine times cosine. Let's do the same thing with cosine, and let's make alpha and beta the same angle, see what happens there. Imagine doing cosine of alpha plus alpha, see? It would be cosine of alpha minus sine of alpha, sine of alpha. All my betas are alphas now. And simplifying that, it would look like this. Cosine of 2 alpha, that's what the left side looks like. And how do you write cosine times cosine? Isn't that cosine squared? So that'd be cosine squared alpha. And what's sine alpha times sine alpha? Sine squared alpha. And this too is a new one for us. Okay, so cosine of twice an angle is cosine squared of the angle minus sine squared of the angle. Okay, now, you also notice that this formula, the one I just wrote, actually has a cosine squared in it, right? So I could actually replace this cosine squared with a 1 minus sine squared. I could do that. What would it look like then? Let's see. Okay, let's try it. This is just for fun. I'm going to change this to 1 minus sine squared alpha. If I do that, it's going to look more like this. Cosine 2 alpha
equals 1 minus sine squared minus sine squared. In other words, 1 minus 2 sine squared alpha. So what I'm saying is there's another version of this same formula (1 minus 2 times the sine of the angle squared). But why stop there? Why not instead change the sine squared into a 1 minus cosine squared? This will give us a third version of the formula. So imagine changing this to a 1 minus cosine squared. You could do that too. This would give us 2 cosine squared alpha minus 1 for yet a third version of this same formula. 2 cosine squared alpha minus 1. So this is an interesting formula, this second one I'm teaching you today, because there are actually 3 versions of it. So I'm talking 2 formulas, and the second one has 3 versions. Okay, let's set the timer for 2 minutes and see if you can come up with the formula for tan of alpha plus alpha. Probably don't even need 2 minutes. Let me just give you 1 minute for that. We're trying to get tan of alpha plus alpha by modifying our tan sum formula. I'll let you do that one. Okay, so you would be doing tan of alpha plus tan of alpha over 1 minus tan of alpha times tan of alpha. In other words, this would just give you tan 2 alpha is 2 tan alpha over 1 minus tan squared alpha. Did anyone get that? Good, good. Okay, so we have some brand new identities, and the second one has 3 versions. And over on this board, I'm just using theta just to be consistent with the way I've written all my others. Okay? Okay, so how do you actually use this? Well, the questions are very similar to 6.4 questions, except they're actually a little bit easier because there are not 2 angles. There's only 1 angle going on. Here's an example here. Why don't you take a minute and copy that question. Okay, so it's kind of up to you if you want to draw a picture or not. I personally like to do that, just so I can get my mind around the problem. Think of this as y and r. And think of this right here as just 180 to 270. So this is just their way of saying quadrant 3. That's all. Okay? All right. So a quick drawing in quadrant 3, where the y is negative 2 and the r value is 5. Okay? And let's find our missing coordinate. So you would just do x squared plus 4 equals 25, and you get x squared equals 21, x equals plus or minus rad 21. Let's go with the negative because we're in quadrant 3. So that says negative root 21 for the x. Kind of messy, let me rewrite it. Negative root 21. There we go. Okay, now we just have new formulas, that's all. But we're still going to use this picture to solve the problems. So first they wanted sine 2 theta. And that's supposed to be found by doing 2 sine theta cos theta. We'll just get the sine theta and the cos theta from the picture. So let me circle my picture in green here. Just focus on this. Sine would be y over r. Cosine would be x over r. So it's basically going to be negative 2 over root negative 2 over 5. And the other one is cosine, that's negative root 21 over 5. So you just basically get 4 root 21 over 25. Okay, let's go on and look at cosine. Now, I have 3 options for this guy. I could use any of the 3 formulas that I wrote down today. It's totally up to me. I kind of like the third one, actually. I don't know why. I like that it's just 2 times cos squared minus 1. I don't have to deal with any negatives in front of anything. So I'm just going to go 2 times cos squared minus 1. So it's going to be 2 times, and then I got the negative root 21 over 5 here. I'm not really scared of that radical because I'm squaring anyway, right? So this just basically gives me negative, it's just going to be 21 over 25, so it's going to be 42 over 25, and you're subtracting 1, so that's 25 over 25. So this just comes out to 17 over 25. Listen, you could have used any of the 3 formulas on the left. They all work. And to get tangent 2 theta, you would just do basically 2 times tan theta over 1 minus tan squared theta. And you know you have to clean up that radical. In the end, you're going to get this 4 root 21 over 17. I know that because that's what you get when you divide sine over cosine from up above. But you should take the time to figure that out.